Today you're going to learn Section 2 of Chapter 11, Probability. There are two types of probability, experimental probability and theoretical probability. Experimental probability is the probability of an event based on physical data that has been gathered, like a survey. Theoretical probability is based on mathematical principles and the idea of equally likely outcomes. Theoretical probability might be used in the case of rolling dice, or cards, or spinning a wheel, or flipping a coin. Okay, so experimental probability, we're going to fill in this definition now. So the probability of an event, if it's experimental probability, is the number of times an event occurs divided by the number of trials. Theoretical probability is found by the number of what's called favorable outcomes. Divided by the total number of outcomes. Here's an example of experimental probability. Of 60 vehicles in a lot, 15 of them are trucks. What is the probability that a randomly chosen vehicle is a truck? Now, I'm sure you've done problems like this before, and you probably already know the answer. And that is 15 over 60, because 15 of the vehicles are trucks, and there are 60 total. And that can be reduced to 1/4, which is also 0.25, or 25%. Any of these are acceptable ways to represent probability. Even this is okay too, but if you're asked to present a simplified fraction, then you would not include 15 over 60. But probability is written as a fraction, as a decimal, or as a percent, and really any of them are acceptable. Let's try another example of experimental probability. Of 200 people interviewed, 23 of them said their favorite color is yellow. What is the probability that a randomly chosen person's favorite color is yellow? Well, of the people who were surveyed, how many liked yellow? 33. And how many people were surveyed altogether? 200. Now, let's take our calculators and figure out what that is as a decimal. That's not a fraction. That can be simplified, of course, because 23 is a prime number. But if we were to type this in our calculators, we would find that the decimal equivalent is 0.115, or 11.5%. The next thing we're going to talk about is sample space. Sample space is the set of all possible outcomes to an experiment or event. And now we're going to talk about theoretical probability. And in that will come some examples of sample space. A 6-sided number cube is rolled. That's called a die. As you see over here on the right, I have some pictures for you. Write the sample space of this event. Well, if we're only rolling one die, there are 6 things that could happen. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. That's the sample space because those are the events that could happen when I roll a die. What's the probability of rolling a 5? Well, I can only roll a 5 one way, and that's to roll a 5. So because there's only one way to roll a 5, and there are 6 possible things that could happen, then the probability is 1/6. Okay, now let's consider that 2 dice are rolled. Pretend one die is blue and the other is black, like these pictures here. Consider the sample space of this event. I didn't want you to write the sample space of this event because that would be an awful lot to write. But let's think of some of the things that could happen. Well, you could roll a 1 and a 1 on the black die and a 1 on the blue die. You know what? Let me actually even change these colors to black and blue. So I could roll a 1 and a 1. I could also roll a 1 and a 2. I could roll a 1 and a 3. Now, obviously, I could keep going, but let's not get nuts. That would take all day. So how many different numbers could be rolled on the black die? Well, that would be 6. And how many different numbers could be rolled on the blue die? Well, that's 6. This is really the fundamental counting principle. How many different ways can you roll a number on the black die? 6. How many different ways could you roll on the blue die? 6. And the fundamental counting principle that we learned last week tells us that we should multiply these together. So there are 36 possible outcomes that could happen when you roll 2 die. And coincidentally, that's the answer to the next question. Okay, what are the possible ways you can roll a sum of 5? Okay, so that means adding them together. So I could roll a 1 on the black die and a 4 on the blue die, and that would give me 5. I could roll a 2 on the black die and a 3 on the blue die, and that would give me a total of 5. Clearly, I've been using my Apple Pencil too much. 3 on the black die, 2 on the blue die, or 4 on the black die, and 1 on the blue die. I can't think of any other ways I can roll a sum of 5. So that's 1, 2, 3, 4 different ways. So what's the probability of rolling a sum of 5? Well, we found 4 different ways we could get a 5, and we know that there are 36 different outcomes that could occur. So 4 out of 36 reduces to 1/9, and that is 0.11111 repeating as a decimal, or 11.1%. Yes, I just double-checked that on my calculator to make sure. Okay. Find the probability of rolling an even number on one roll of a die. Well, how many of those numbers are even? We could get a 2, we could get a 4, we could get a 6. Those are the only even numbers. So how many even numbers are there? There are 3. And there are 6 possible things that could happen when I roll a die. So 3 are even, 6 is the total. So these are the favorable outcomes. This is the total number of outcomes. And that, of course, could be reduced to 1/2, 0.5, or 50%. So those are some things you probably already knew, but nice little review. And there's still more to come, but we can save that for tomorrow where we're going to talk about cards. So please use these notes and attempt the homework problems. And then I'll see you tomorrow and we can answer any questions.